Welcome everyone. I'm Professor Richard Holowczak, and this is the Converting Entity Relationship Models to Relational Models lecture. If you've been following our lectures so far, you are intimately familiar with the database development lifecycle, during which the project team identifies an organizational problem or opportunity. This is documented by gathering requirements and interviewing users. Based on those requirements, a conceptual data model is created using the entity relationship modeling technique. If this is the first time you're hearing about entity relationship modeling, please go back and review earlier lectures, as this lecture assumes that you know all about ER modeling. You should be familiar with things that look like this. This is an employee entity relationship model, which features things like one department may be staffed by many employees. One employee may be submitting many timesheets, and one timesheet may be paid with one or more paychecks. Another example is the student ER model, where one student must be declaring one and only one major. One student may be renting one and only one locker, and one student may be signing up for one or more clubs. This model has a few assumptions: that students can only declare one major, students can only rent one locker, not all students will rent a locker, and students can sign up for as many clubs as they like. And this is another very, very common entity relationship model, where one vendor may be receiving many purchase orders. A purchase order may be made up of one or more purchase order items, and a product may be ordered on one or more purchase order items. This model also features the ID-dependent entity purchase order items. Again, if any of this is completely new to you, please go back and review some basics of entity relationship modeling. We're going to move on to the next step. Once we have agreement on the entity relationship model, the next stage in the life cycle is to convert that conceptual model into a logical data model. And in this example, we are using the relational model. So our ER model will turn into the relational model. When we were building our entity relationship model, we were concerned with things like entities, attributes, identifiers, instances, which are examples of the actual data, and relationships among the entities. When we convert to the relational model, our entities will become relations. Our attributes are also called attributes. The identifier of our entity will become the key of the relation. Instances will turn into what we call tuples or rows, and the relationships between entities will turn into foreign keys in our relational model. It's important to keep this vocabulary consistent. If you're talking about entity relationship modeling, you should use terms like entity, attribute, identifier, instance, and relationship. Once we go over to the relational model, we're going to talk about relations, attributes, keys, foreign keys, and tuples. The conversion process is relatively straightforward. It is typically going to follow 4 basic steps. In these 4 steps, the name of the entity will turn into the name of the relation. The attributes of the entity will become attributes of the relation, and the identifier of the entity will become the key of the relation. These 3 steps are usually quite straightforward for virtually all of the entity relationship models we come across. The 4th step is to convert relationships, and here's where we have a bit of variety. Depending on the type of relationship, we have a few different alternate ways to deal with it. For one-to-many relationships, we're going to copy the key from the one side over to the relation on the many side. For one-to-one relationships, we can copy a foreign key to either side, but not both. And for many-to-many relationships, we're going to create a new relation called the intersection relation, and that will allow us to tie together 2 relations in a many-to-many relationship. We'll go through examples of all of these types, and hopefully you'll get the hang of it pretty quickly. So to get started, the first question is where to begin. Assuming we have the following entity relationship model of department, employee, timesheet, and paycheck, the question comes, which should be the first entity to convert to a relation? And the general rule to follow is to look for entities that only appear on the one side of one-to-many relationships. So if we look at, for example, the department entity, department is on the one side and employee is on the many side, meaning one department may be staffed by many employees. So this is actually a good candidate. If we try to start with the employee entity, notice that yes, employee is on the one side here, submitting many timesheets, but employee also appears on the many side of this relationship. So we wouldn't necessarily want to start with employee, timesheet, or paycheck. The best place to start here is with department. So we're going to start our conversion process with the department entity. So I've tried to block off the rest of the model so we can just focus on one entity at a time. And so we've decided department is the place to start, and we'll follow our 4 steps. The first step, the name of the entity department becomes the name of the relation. So we simply just write it out on a line here. The next step, all of the attributes of the entity will become attributes of the relation. And if it looks like we've just taken our entity and kind of laid it down on its side, you would be correct. That's pretty much what we're doing. Just take everything that's inside here and copy it out in the relation. The third step, the identifier of the department, in this case it's department ID, will become the key in the relation. So down here we have our department relation. Department ID we now say is the key. And the fourth step is to convert any relationships. Now, because department only appears on the one side of a one-to-many relationship, there's nothing to do for this fourth step for the department entity. And this is, again, another reason why we like to start off with a simple case. Department is only on the one side, therefore our relation is done. So we have successfully converted the department entity to the department relation. We see the department name here. The department ID is the key for the relation. We have department name, department city, and department state. Now that department has been converted, we can move on to the next entity. And the easiest way to do this is just to follow the one-to-many relationship over. So we move from department over to employee. And as before, the name of the entity employee becomes the name of the relation. We copy in all of the attributes from employee all the way down to social security number. It's okay if the list of attributes goes on to the next line. That's not a big deal. You can just keep putting them in between commas and just list them out. The third step is that the identifier of the entity will become the key of the relation. So our employee ID was the identifier, it comes down here, and now it becomes the key for the employee relation. And now the fourth step, and here's where we have to pay a little bit of attention. We need to take care of our relationship between department and employee. Department is on the one side of the relationship, and employee is on the many side. And so our instructions here tell us we're going to copy the key from the one side over to the relation on the many side. So here is department, and the key is department ID, and we will copy that over to the employee relation, where it becomes a foreign key. So we think about it. Department ID is the key for the department relation, but here it is showing up in another relation. They say, hey, you're not from around here, you are a foreign key. All right, so department ID becomes the foreign key in the employee relation. And now our employee conversion is completed. We now have two relations. Department relation with department ID as the key, employee relation with employee ID as the key, and it also has department ID as a foreign key. 2 down, 2 to go. Now we just follow the relationship around again. Now we're going to work for timesheet. Okay, as before, the name of the entity becomes the name of the relation. I've eliminated some spaces and tried to clean things up a little bit just to get it a little bit easier to work with. Second step, we copy in all of the attributes from timesheet ID all the way down to pay period end date. The identifier of the entity becomes the key of the relation. So timesheet ID was our identifier. Timesheet ID down here becomes the key for the timesheet relation. And then, fourth step, now we have to convert relationships. So here we are looking at this relationship between employee and timesheet. One employee may be submitting many timesheets. So employee now is on the one side, and timesheet is on the many side. One employee submitting many timesheets. Therefore, we copy the key from the one side, that's employee ID, and we put it down here in the relation on the many side. So employee ID becomes a foreign key in the timesheet relation. Notice we didn't copy department ID in this situation. We've already taken care of the foreign key that connects employee to department. We don't need to worry about that. For this conversion, in timesheet, we're only interested in connecting timesheet back to the employee that submitted that timesheet. So we really only need one foreign key here, and that's all we need. And now, timesheet conversion is done. We have 3 entities. So far, we have 3 relations, department with department ID, employee with employee ID as the key, timesheet with timesheet ID as the key. Well, there's only one left. Now we can work on paycheck. As before, the name of the entity becomes the name of the relation. We copy in all of the attributes from paycheck ID all the way down to check date. The third step, the identifier, paycheck ID, becomes the key of the paycheck relation. And once again, we have to deal with foreign keys. This time, timesheet is on the one side and paycheck is on the many side. So we're going to copy the timesheet ID from timesheet over to paycheck, where it becomes a foreign key. And that's it. Paycheck has now been completed. So we've got 4 entities that turned into 4 relations. And we can see how they are connected through their foreign keys. This is probably what you will see most of the time. You'll see a bunch of one-to-many relationships, and we just have to connect them by copying over our foreign keys. We'll call this the initial set of relations. So from this entity relationship model, we do the conversion, and now we have this initial set of relations. Some things to watch out for. Make sure we use the exact same spelling of all entity and attribute names. Don't use abbreviations, spaces, or punctuations, except sometimes we use the underscore, but aside from that, no abbreviations, spaces, or punctuations. We're only going to copy the key from the one side over to the many side, not the other way around. In other words, we didn't copy employee ID into department, we copied department ID over to employee. There's no need to copy a foreign key onto the next relation. So once we've copied it once, we don't have to keep copying it to the next relation in the diagram. And finally, in our initial set of relations, just show each relation one time. You don't want to show 2 employees or 2 timesheets or 2 paychecks. We just show each relation once, and that finishes it. Sometimes students are curious as to how the foreign keys help us out. All right, here's an example. Here's some data for the department table, a department relation, I'm sorry. We can see department ID D1, D2, D3, accounting, IT, and marketing. And then we have some employees. And if we look over here at the department ID, we can see those department IDs that are connected to the department relation. So we know that Joe and Mary are in the accounting department, Sally is in the IT department, and Alex is in the marketing department. Going further, we can look at some timesheets and we can see which employees submitted those timesheets just by looking at the employee ID foreign key. So we can see that timesheet 900, 924, and 931 were submitted by Mary. We can see that timesheet 903 was submitted by Joe, and timesheet 929 was submitted by Sally. We can go a step further, and we can look at the paycheck relation. And we can see that timesheet 900 turned into paycheck 44-101. Timesheet 903 turned into paycheck 44.111, and so on. So by using these foreign keys, we can connect each of the relations together. If you'd like to know who submitted or who received paycheck 44.323, we follow back to the timesheet, timesheet 929. We see that that was employee 103. We go back to the employee relation and we see that that was submitted by Sally. That's all we need is one way to connect each of our relations together. All right, now it's your turn. We have here an example from a firehouse. We see that one firehouse may be equipped with many fire trucks, and one fire truck must be assigned to one and only one firehouse. 4 questions. Which entity should we convert first, firehouse or fire truck? How many relations will we end up with once the conversion is complete? How many attributes will the firehouse relation have? And which relation will end up with a foreign key? So I invite you to pause the video for a few seconds and jot down answers to these 4 questions. Once you've done that, you can play the video again and see how you did. Okay, here's our conversion. It turns out we got started with Firehouse because Firehouse only appears on the one side of our one-to-many relationship. So we convert Firehouse, Firehouse ID is the key, and we have all of the attributes from the Firehouse entity copied into the relation. Then we worked on Firetruck. Firetruck ID is the key, and because Firehouse is on the one side, Firetruck is on the many side, we get the Firehouse ID copied over as a foreign key. Hope you did well with that. Feel free to review this part of the video until you are certain you understand how to do this type of conversion. Not all relationships are one-to-many. Sometimes we have one-to-one relationships or many-to-many relationships. And so here's an example of an ER model that has a little bit of a mix. We have one major may be declared by many students. We have one locker that may be rented by one and only one student. And we have a club that may be attended by one or more students. We have the same assumptions that we talked about before. To convert this to a set of relations, where should we start? It looks like major is a good place to start because it only appears on the one side of a one-to-many relationship. So we're going to begin with major. All right, just like before, the name of the entity becomes the name of the relation. Next, we copy in all of the attributes. Third, the identifier major ID becomes the key of the relation. And then fourth, we convert our relationships. For major, there's nothing we need to do because major only appears on the one side of a one-to-many relationship. So nothing more to do for major, we are done. Now we can move on to student. The name of the entity becomes the name of the relation. We copy in all of the attributes. Don't worry if it goes on to another line, that's perfectly fine. The identifier of the entity becomes the key of the relation. So student ID is the identifier, it becomes the key for the student relation. Now we need to worry about our relationships. So major is on the one side, student is on the many side. Therefore, we copy the key from the one side, major ID, and it becomes a foreign key in the student relation. This is the same pattern that we saw in the prior example. Now let's move on to locker. As before, the name of the entity becomes the name of the relation. We copy in all of the attributes. The identifier of locker is locker ID. That will become the key of the locker relation. And now we have to deal with foreign keys. Logically, when we have a one-to-one relationship, a one over here and a one over here, one student may be renting one and only one locker may be rented by one and only one student. These are the ones, so it's a one-to-one relationship. Logically, we can copy either key to either side. We could copy student ID into locker or locker ID into student. The point that I wanted to come back to is that not all students have lockers. So in this case, it makes sense that we copy the student ID from the student relation into the locker relation as a foreign key. It kind of looks a lot like what we just did for the one-to-many relationship. And it's true, it does kind of look a little bit like that. Typically what we'll do is, if not all students would have a locker, it makes more sense to put the student ID over in locker. If it were the other way around, we could probably move locker ID, but this is the logically slightly better way to do it. Okay, last one up now is club. The name of the entity becomes the name of the relation. We copy in all of the attributes. Club ID becomes the key for the club relation. And now we have something brand new. Now we have a many-to-many relationship. One student may be signing up for many clubs, and one club may be attended by many students. This is a many-to-many relationship. Whenever we have a many-to-many relationship, we have to create a new relation. We call it an intersection relation. And there are 3 steps to do this. First, we take the names of the 2 relations involved here. In this case, it is student and club. And so we simply take those 2 names and we stick them together. In this case, I put a little underscore between them. It doesn't matter what the names are. If they're in a many-to-many, we create a whole new relation and we stick the 2 names together. The next step is to copy the keys from both sides. We copy the key from student, which is student ID, and we copy the key from club, which is club ID. Because student ID is a key, but it shows up in a different relation, we say that it is a foreign key. Club ID is a key. In club, it shows up in another relation. We call it a foreign key. The last step, the keys, the foreign keys I should say, in student club will form the key for the relation. This is what we call a composite key. A composite key is a key that has two or more attributes stuck together. All of our other keys that we looked at so far were very simple. They just had one attribute as the key. This is our first example of a composite key. We could also say that student club relation is all key. All of the attributes that are in there form the key. Student ID and club ID together form the key. So now we see a situation where 4 entities have turned into 5 relations. So what's the story here? As long as we're dealing with one-to-many or one-to-one relationships, I should say, every entity will be represented by a relation. When we have a many-to-many, like we did between club and student, we're going to create this new intersection relation. So a couple of things to watch out for. For one-to-one relationships, we can copy the key to the foreign key in either direction, but only in one direction. In many-to-many relationships, we create a new intersection relation. Do not copy the keys into each other's relations. Notice we didn't copy club ID into student or student ID into club. Instead, we create something that is brand new called student club. The intersection relation is all key, meaning all of its attributes make up the key. So here's a couple of new things that we did. We've been looking at one-to-many relationships. We've now dealt with one-to-one relationships and with many-to-many relationships. As before, I wanted to provide a little bit of sample data. Here we can see some majors with their major IDs, and we can see some students. And check it out. The major ID is the foreign key, so we see that Bill is a CIS major, Sally is a CIS major, Alex is majoring in finance, Sarah's majoring in accounting, and so on. If you're interested in what clubs they signed up for, here's some club IDs. CC1 is the CIS club, and so on. And here we have student club. So now we can see that S101, that's Bill, has signed up to go to the CIS club. S103 is Sally. Sally has also signed up to go to the CIS club. And let's see. S105 is Ted and S101 is Bill. They are both signing up for the knitting club. So many-to-manys with this intersection relation, they give us a lot of flexibility. We can connect up any student to any club in any combination we like. Over here with the locker, we can see a particular locker is being rented by, that looks like Sally. Locker 5001 has been rented by Ted. Locker 5002 is rented by Bill, and so on. So the foreign keys, again, help us keep everything connected together. All right, it's your turn again. Now we've expanded our firehouse model. We've got the firehouse and the fire truck, and now we have a new entity called emergency call. One emergency call must be responded to by many fire trucks, and one fire truck may be dispatched to many emergency calls. Again, we ask the question, which entity should we convert first? How many relations will we end up with once the conversion is completed? How many attributes will the fire truck relation have? And which relations will end up with foreign keys? Again, I invite you to pause the video, write down some answers, and then you can go ahead and press play again and see how you did. Okay, back again, here are the results. Firehouse looks like the right place to start because it only appears on the one side of a one-to-many relationship. As before, it's the same relation with Firehouse ID as the key. We converted Fire Truck next. Fire Truck ID is the key, and we have Firehouse ID as the foreign key. Then we converted Emergency Call. That has Call ID as the key, and that's it. No foreign keys in Emergency Call. But what do we have here? We have a many-to-many relationship. Therefore, we need an intersection relation. We create that by sticking together the two names, fire truck and emergency call. And we copy in the fire truck ID and the call ID, where they are both foreign keys, and they create the key for the fire truck emergency call relation. So from 3 entities, we end up with 4 relations in this case. Once again, if you're not quite certain on how that worked, go back and review this section and give it another try. Okay, this is the third comprehensive example that I have prepared. And the reason why I wanted to show this example is it is very, very common. You could use this pattern for any type of product or service that a company or organization might want to sell or purchase. You could easily replace purchase orders with customer orders, vendors with customers, and so on. It all works. One vendor may be receiving many purchase orders. One purchase order may be made up of many purchase order items, and one product may be ordered on many purchase order items. The interesting part about this model is that the item number, which is typically an integer, item 1, item 2, item 3, sometimes it's called the line number, is an identifier, but it is not sufficient to uniquely identify a purchase order item. Hence, we say that purchase order items is ID dependent. And we're going to have to treat purchase order items as a kind of a special case when it comes to converting to a set of relations. First question, as always, is where to start the conversion process. And in this case, both vendor and products are on the one side of one-to-many relationships. So we could actually start with either one. Just for fun, I said let's start off with products. And now we're going to move a little bit more quickly because I think by now, hopefully you got the hang of this. You can always pause the video and make sure that you understand each of the steps. I actually put 2 steps together here. We're converting products. We got the name of the relation, and we copied in all of the attributes. And now for step 3, product ID becomes the key. And then there's nothing to do for foreign keys because the products entity only appears on the one side of a one-to-many relationship. So that's it. Products gets converted, very, very straightforward. We can also work on vendors. Again, I did 2 steps at a time. We've got the name of the entity becomes the name of the relation, and we've copied in all of the attributes. The identifier becomes the key. Vendor ID becomes the key for the vendor's relation. And again, there's nothing to do for vendors as far as relationships are concerned because vendor only appears on the one side of a one-to-many relationship. Because we've finished vendors, now we can move over to purchase orders. And again, I've done a couple of steps here. The name of the entity becomes the name of the relation. We've copied in all of the attributes. Step 3, the identifier purchase order ID becomes the key for the purchase orders relation. And now for step 4, we have to pay attention. Purchase orders is on the many side of a one-to-many relationship. Vendors is on the one side, purchase orders is on the many side. Whenever we have this situation, we copy the key from the one side over to the relation on the many side. All right, so typical key copied over to foreign key, and we are all done with purchase orders. That leaves purchase order items. Again, did a couple of steps here. Purchase order items becomes the name of the relation, and we've copied in all of the attributes. The identifier in the entity becomes the key of the relation. So item number becomes the key. However, because purchase order items is ID dependent, we're going to have to come back and revisit it. Again, ID dependence is a very, very special case that we have to treat a little bit differently. So I'm actually going to bounce back to step 3 in a minute. Now we have to convert our relationships. And here's something else that's a little new. There are actually two different one-to-many relationships that lead us into purchase order items. In the first case, we have products. Products is on the one side, purchase order items is on the many side, so we're going to copy product ID over as a foreign key down here in the lower right corner. In this other relationship, purchase orders is on the one side and purchase order items is on the many side, so we're going to copy purchase order ID over to purchase order items as a foreign key. So this is something, again, that's new. We have two foreign keys to deal with. Finally, we have to jump back here. Purchase order items is ID dependent. It depends upon another entity for its identifier. And in this example, the other entity that it relies on is purchase order ID. So when we convert to a relation, we need to indicate that both item number and purchase order ID will form a composite key. We bring these two together to form the key of purchase order items. If you ask me, hey, what is the key for purchase order items? I would answer, purchase order ID and item number stuck together. Go to purchase order 101 and look at item 3. Those two pieces of data have to come together to uniquely identify exactly one purchase order item. This is only going to happen when we have an ID-dependent entity. And as I've probably already mentioned in lecture, this is very, very rare that we would have an ID-dependent entity. So here's our initial set of relations. Products turned into products, vendors turned into vendors, purchase orders turned into purchase orders with vendor ID as a foreign key, and then this very special case, purchase order items with purchase order ID and item number as the key, as a composite key, as well as product ID as a foreign key. A couple of things to note. Attributes in a relation can be listed in any order. Just for convenience, we usually write out the key first, then all of the other attributes, and then any remaining foreign keys go at the end. Multiple one-to-many relationships will end up with more than one foreign key. And finally, this topic we've been talking about here, this very special, very specific case, ID-dependent entities will convert into relations that have a composite key. Again, very rare, very special case for ID dependence. Here's some example data to show you how everything would be put together. Here we've got some products, we've got some vendors, and we've got some purchase orders. So who submitted purchase order, or sorry, who did we submit purchase order 105 to? We follow it back using the vendor ID. That went to vendor 10. Okay, we can see their contact information. If we want to know what all is on purchase order 105, we can go to purchase order items and we can see that there is one item there. Purchase order 105, line number 1. We ordered 200 of product 120. Product 120 is a yellow t-shirt. If we're interested, let's say, in purchase order 100, that also went to vendor 10, and we can see that there are 3 item numbers. Purchase order 100, item 1, that's product 100, a blue t-shirt. We ordered 500 of the red t-shirts, and we ordered 400 of the yellow t-shirts. Okay, those are all under purchase order ID PO 100. Again, notice why we have to make this the key. We need a combination of the purchase order ID and the item number to make a unique key that can then identify exactly one row or tuple in our relation. Okay, once again, it's your turn. Back to the firehouse example. Now we've added firefighters, and we see that one firehouse may be staffed by many firefighters. and one firefighter may be driving one and only one fire truck. Notice not all firefighters are drivers, okay? And if they are a driver, the thing they're driving is a fire truck. Everything else, emergency call and firehouse, are the same. So we ask these questions: which entity should we convert first? How many relations will we end up with once the conversion is completed? How many attributes will we have in the fire truck relation? And which relations will end up with foreign keys? For the third time here, I invite you to pause the video, see if you can jot down some answers, and then you can go ahead and play the video and see what we have. Okay, here it is. It's a little messy looking, but I think I've got everything in one place. Firehouse is exactly as it was before with the firehouse ID. We next converted firefighter, and we can see that firefighter ID is the key and firehouse is the foreign key. Because of the one-to-many relationship, firehouse ID ends up in firefighter. Next, we did fire truck. Notice we have the foreign keys for firehouse ID as well as the firefighter ID. So this is a one-to-one relationship, and the hint was that not all firefighters drive fire trucks. Therefore, it's best to put the firefighter ID in the fire truck relation. Emergency call is the same as it was in the last example. And again, we need this intersection relation because fire truck and emergency call are in a many-to-many relationship. So 4 entities resulted in 1, 2, 3, 4, 5 relations. Okay, the last 2 examples that I have to show you are kind of special cases. They don't come up a lot, but I just wanted to give some 2 more examples in case you do come across these. The first is there are some situations where 2 entities might have multiple relationships. A perfect example of this is an airline having flights, and there are airports. When you get on an airplane and you fly, you depart from one airport and you arrive at another airport. I guess theoretically you could parachute out in the middle, but let's assume for this example, you leave from an airport and you arrive at an airport. So there are 2 relationships. One airport may be the departing location for one or more flights, and one airport may be the arriving location for one or more flights. One flight must be departing from one and only one airport, and one flight must be arriving at one and only one airport. Okay, so hopefully this logic makes sense. When we do the conversion, we can convert airport because airport only shows up on the one side of one-to-many relationships. That's very straightforward with our airport ID as the key. When we convert flight, we copy everything in and we have flight ID as the key. But look what we need to do. Normally we would take airport ID and we would copy it in as a foreign key. However, because we have to do this twice, we're going to need to change the names a little bit. And this is allowed. I think only in this case I would do it. Departing airport ID implements this first relationship. So this is going to be the airport ID of the airport the flight is departing from. And then we have arriving airport ID. This will be the airport ID of the airport where the flight is arriving. So 2 relationships resulting in 2 foreign keys. We can't use the same name, airport ID, 2 times, so we just modify them so they have some meaning. We know which airport we're departing from and which airport we're arriving to. And the last special case I want to talk about is that of a unary relationship. In this example here, we have one employee may be supervising many other employees, that's down here, and at the same time, one employee may be supervised by one and only one employee. So everybody has a supervisor that they report to. One supervisor may be managing many employees. When we convert this to a relation, we start off in the normal way, employee with employee ID. We copy in all of the attributes. But what does a one-to-many relationship tell us to do? We should take the key from the one side and copy it to the many side. Well, because this is a unary relationship, that is a relationship with an entity to itself, we can't just put employee ID directly in here because we already have an employee ID. So instead, we're going to call it employee supervisor ID. And now this foreign key will hold the employee ID of the person who is the supervisor. So this is how we deal with unary relationships. Again, we kind of have to rename this foreign key a little bit. There's a few other cases that I think this might come up. Some things like if we have customers who can refer other customers for a particular product or service, or sometimes we would have in manufacturing, we would have parts that have components, which are also parts and so on, sub-assemblies, things like that. That's also a situation where we might have something like this. Okay, in summary, I think we got all of the right steps. We're converting our conceptual model to our logical model. Our entity relationship diagram becomes our relational model. We've got these 4 steps. Usually the first 3 are pretty straightforward. The 4th step of converting relationships is where we have to really pay attention. And then we have a handful of special cases where we just need to be careful with how we treat the foreign keys. Once we have our relational model, we can go and implement that in a physical database. However, the next step that we're going to talk about will be optimizing that logical model through a process called normalization, but that is a lecture for another day. That's all I have for today. As usual, my additional notes on databases and data warehousing can be found on my website, and I hope to see you all in the next lecture.